A very good morning to all my dear students. So today we are going to continue with the chapter circles. Okay, so in this we are going to study that equal chords and the distances from the center. So in this section you have two theorems, theorem 10.6 and theorem 10.7. Okay, so these two theorems you just have to understand. Proofs are not included. So both the theorem. So what is the first theorem? That equal chords of a circle are equidistant from the center. That means you all know what is a chord. Now you are given a circle and it is given. In short, if you want, you can see this I have written over here, the theorem. The theorem says if PQ is equal to RS, PQ is one chord and RS is the other chord. So if PQ is equal to RS, then OL is equal to OM. You know what do you mean by a perpendicular distance? So when you are constructing a perpendicular from any point on the line, then it becomes the distance of that line from the center. So in this theorem it is given if the chords are equal, then they will be at an equal distance from the center. So if PQ is equal to RS, then OL will become equal to OM. So you can prove this also by joining this. Okay, if you will join this and you will join these two lines, if you will join, then you will see these two triangles and you will make these two triangles congruent, and after making them congruent you will just prove it, because you can see if we just join this one and we join this one. Okay, so you have already studied the theorem that perpendicular from the center bisect the chord. Okay, so if PQ is equal to RS, half of PQ will be equal to half of RS. So this will be equal to this side. This side is equal to this side. Reason is, what is the reason behind this? These are the two radii of same circle. This angle is equal to this angle, each 90 degrees. So these two triangles are congruent by right hypotenuse side. So RHS से ये दोनों triangles congruent हो गए, and then you can prove that OL is equal to OM by CPCT. Okay, so this is the proof. Simple it is. If time requires, then I will give you the proof in return also. And understanding part I have explained you. You have to join. Okay, radii of same circle, chords are equal, so half parts will also be equal. This is 90 degree. If this is 90, this will be 90. So by RHS, these two triangles are congruent. Then OL is equal to OM by CPCT. So this is theorem 10.6. Now similarly, theorem 10.7 is just the converse. That if two chords are at an equal distance, then they must be equal. So this also proof goes the same way. You have to join these two. Okay, and again, now in this part it is not given that these two chords are equal. तो ये side हम equal नहीं ले सकते. Now in this case, this side will be equal to this side. Radii of same circle. This will be equal to this given to you, and this is 90 degree. This is 90 degree equal. So again these two triangles are congruent by right hypotenuse and any one side. So if you have proved that these two triangles are congruent by RHS, then PL will be equal to RM. Okay, and you know perpendicular from the center bisect the chord. So if PL is equal to RM, then twice of these will become PQ, twice of RM will become RS. So the chords will also become equal. So this is the understanding part of the theorem. So these are the two theorems. Now we'll solve the exercises based on these theorems. So you can see this is the first question of exercise 10.4. Okay, so in exercise 10.4, first question, it is given that two circles are intersecting each other at 2 points P and Q. Okay, and radius of the bigger circle is 5 centimeter, radius of the smaller circle is 3 centimeter. Okay, and the distance between their centers, suppose O1 is the circle with radius 5 centimeter, O2 is the circle with center O2 with radius 3 centimeter. So O1, O2, the distance is 4 centimeter. So these three things are given to you. You have to find out the length of common chord. So you know what is the common chord? PQ. So you have to find out the length of PQ. So first of all, line joining the line joining the centers bisect the chord. This is the question we have done in exercise 10.3, that any line which joins the two centers of a circle is perpendicular bisector of the common chord. So O1 O2, this line O1 O2 is the perpendicular bisector of PQ. Okay, so it means that PT, this small part, is equal to TQ. Okay, PT is equal to TQ, and this angle is equal to this angle. All these four angles are of 90 degree. Now we'll consider this triangle, the upper triangle I'm shading. Okay, this side I'm shading and this side I'm shading, these two triangles. Now suppose the full distance, you know, it is 4 centimeter. Suppose O1T, this one is x, then the other distance will be 4 minus x. So now you have to use Pythagoras theorem in the first triangle, the left side triangle, that is O1PT or PTON, you can say in any way. So hypotenuse square, you can see in the diagram, 5 square is equal to PT square plus x square. So from this you will get equation number 1, which is PT square is equal to 25 minus x square. Similarly, in the second triangle, the right side triangle, you will again use Pythagoras theorem and you will get the equation PT square is equal to 9 minus in bracket 4 minus x whole square. So now this is also PT square, this is also PT square. So you have to compare these two, and when you will compare 1 and 2, you will get the value of x. Okay, so now we'll see further. So you can see that we have equated the two equations. So from this we have got the value of x. So the x is 4 centimeter. X की value आ गई आपकी 4 centimeter. Now you have to use, you remember we have got two equations. So you can put the value of x in any one equation. So you will get the value of PT. Okay, PT दो equations थी PT को लेके, so you can put the value of x in any one equation. You will get the value of PT as 3 centimeter. So if PT is 3 centimeter, PQ, the total length of the common chord, will be double of that, that is 6 centimeter. Okay, so this question is little lengthy, but it is simple. So you have to complete this question and try doing few other questions also. So that's all for today. Thank you.